in the past. In the past, you guys had to solve for angles. You did this with right triangles, and you had to find a theta. We used to just call it a value of x, and you were given side lengths. For example, 3, 7. If you had to solve for theta in a problem like this, you'd have to use an inverse trig function. What inverse trig function would you be using?
Inverse sine.
Inverse sine. What you're saying here is that you know that the sine of theta in this problem would have equaled 3 over 7. In your calculator, not your phone, you would have, put it away, come on. You would have typed in the inverse sine of 3/7. And it gives you some angle. What's up?
The inverses of those will, like the cotangent and the things like that, where are those going from the calculator?
You have to, I'll show you later. We talked about that before you got here. So what you guys did were things like this. And you did that with all of your right triangles last year. And it wasn't difficult. What we're going to do today, though, is work off of it not in the right triangle, but we're going to ask ourselves, what angle has a sine of root 2 over 2? And all of this is going to be built off of 45, 45, 90, and 30, 60, 90 triangles. All of this gets built out of those two scenarios. 30, 60s. We have 1, root 3 and 2. And 45s. 1, 1, root 2. None of that changes. So if I'm sitting here thinking, what angle has a sine value of root 2 over 2, which of those triangles am I working with? Work with the 45s. So what angle has a sine of root 2 over 2? 45. Because you know that in the right triangle, 1, 1, root 2, that has to be a 45-degree angle to get the sine value. So the sine of root 2 over 2 is 45 degrees, or in terms of radians, pi over 4. Okay? Now, is there another spot that has a positive sine value?
The other
Third quadrant or second quadrant? Or which one is it?
terminator. That one.
But here's what's going to happen. We're only going to be looking for sine values to occur in specific quadrants. This is where things get a little bit tricky to remember what quadrants we're going to look for. The reason, I'll explain the reason why we look at these here in a little bit, but when we're trying to find a sine value, an inverse sine value, we're only going to be looking between those two quadrants, first and fourth. Let me show you why. When you have a sine value, it cannot be any greater than 1. As it can't be any greater than 1, and it can't be any smaller than -1. At some point in time, the sine value does occur to become what? It doesn't work out to be 0. All the while, these values here are negative for sine value. These values are positive. If we were in the other quadrants, they're just repeating. Replicants? They're just replicated. Thank you. Me fail English. They're just replicated within the other quadrants, bounced off with referencing. These two quadrants show a continuous values of sine between -1 to +1. Does that make sense? No. Another way that you could look at this, put your pencils down. if sine starts at 0, when it gets to pi over 2, oops, sorry. That's at 90 degrees, right? What's the sine at pi over 2? 1. Pi over 2. I didn't.
Wait, isn't that what
Yeah.
This one's 90.
Sine is there. Now, if you think about what happens as it comes back around, when it's at 180, or at pi, what's the sine value? Because the ordered pair is at -1 and 0. When it gets back down to 3 pi over 2, it goes to -1. When it gets back to 2 pi, it goes to 0. So what's occurring here is you get the sine wave. What I want you just to see here, the reason why we don't pick apart every quadrant to find values of sine as the inverse is a spot here and a spot here, they're horizontal from one another, aren't they? They're going to have the same sine value, so it's replicated. Same idea down here. A spot here and a spot here are replicated between each other. The values between here and here wind up being mirrored. These are the only values we're worried about, because these two values will give us all values between pi over 2, negative and positive as we're going through. It shows all the values between -1 to +1. That's the only reason. It gets into a lot more funkiness if you really want me to show you why it works. Just remember, when you're looking for a sine value, you're looking for sine values between -pi over 2 and +pi over 2. You don't have to get reference angles, you have to get 300 degrees, you're looking at -30 or +60, one of those. That's all you're doing. Okay. So again, you can do something like this. What angle has an inverse sine of -√3 over 2? First thing you do is figure out what triangle you're working with.
36 degrees.
Working with a 30-60, good. If I'm working with a 30-60, the easiest thing to do is just draw it. Which angle has √3 over 2? 60. Now here's the thing. When you're looking at where you're placing it, since I have a negative sine value, that means I'm this direction. And all my answer is -60 degrees or -pi over 3.
Should we write them both or just read
Yes, I'm going to want you guys to write both radians degrees in this.
So is the answer -60?
Yeah. Because -60 is between -90 and +90. -pi over 3 is between -pi over 2 and +pi over 2. That's all you're doing. That's giving you the values of sine. Cosine, a little bit different. Cosine values, we're looking for the change between here to here. When you look at that, for cosine values, if you start your ordered pairs here, you're at 1, 0. We go to 0, 1, and then I finish at -1 and 0. We okay with that? If I look at it two-dimensional graph-wise, if I went completely around the circle, the cosine at 0 is 1. The cosine at pi over 2 is 0. Cosine at pi was -1, and it comes back up. What happens is, let's go these values here are continuous in the curve between 0 to pi. And all that happens then is they replicate themselves into the next two quadrants. So they're just looking for a continuous value. The continuous value occurs between 0 and pi, 0, 180 degrees. So your cosine values, we're just going to look at between those two. I'll show you what happens. If I want to find the cosine of 135, throw it in a degree. Cosine 135 has a reference angle of what? 45, good. So if I'm looking at cosine of 135, reference angle 45 degrees, what's the cosine of 45?
It's 1.
Root 2 over 2.
It's root 2 over 2. But I'm placed into that quadrant. So is it positive or negative? Because the cosine value over there is?
I still look at this with three-dimensional graph.
We build a lot of it later. It's all built off the unit circle. Unit circles are x's and y's. All I went from the ordered pair there, I'm just looking at I'm just watching the x values over a specific period. I'm relating the x values to the periodicity of 2 pi.
Are you using like find the points because you're using like the quadrantals to find the cosine of those?
Yeah.
Oh, okay.
It's the quickest
Okay.
way. Yes, ma'am.
So we found cosine of 135?
Yeah. Yeah. Oh, I worked back. I did what we did yesterday. Yes. I jarbled lessons there. Yes, we did this. The cosine of negative root 2 over 2. We found that the negative root 2 over 2, what angle had the cosine of negative root 2 over 2? Well, that was a 45-degree angle. It's negative, which meant it was in the second quadrant. If I came up 45 degrees off, that meant that the value was 135, or 3 pi over 2. Okay? No, sorry, 3 pi over 4, excuse me. Cosine? No, cosine is second quadrant.
So it's 135 or is it 3 pi over 2?
4.
Or,
3 pi over 4. Okay. It takes a little getting used to. Takes a little getting used to here. Oops, wrong one. Tangent. Tangent's where things get, I wouldn't say, tangent mirrors the idea of sine values. Okay? Tangent, if you start to think about it, to get continuous tangent values, we look at our ordered pairs. 1, 0, 0, 1, negative 1, 0, 0, negative 1. If I look at that, your tangent is what over what in terms of x's and y's and r's? It's opposite over adjacent, so it's y over x, right? So tangent would be y over x. Now, on my vertical quadrantals, can I have a tangent? Can't, because I'm dividing by 0. So what happens here is that you wind up with an asymptote vertical. At pi over 2, or negative pi over 2, your tangent is undefined because you cannot divide by 0. So your curve that you're looking for your tangent values will still be between these values, excluding pi over 2 and negative pi over 2. And just going between the first and the fourth quadrants. So our tangent values are always going to be between our thetas for these when we find the inverses. Oops. Between negative pi over 2 and pi over 2. We don't include them because you can't divide by 0. That's all that means. Yeah.
Why do you say negative pi over 2 instead of 3 pi over 2?
Because if I go to negative 3 pi over 2, if I start at pi over 2 to here, I'm just doing the mirrored image. I want to start with my first round of positive values to my negative positive values.
Okay.
Because if you looked at like a period set of tangent, tangent is repeated every pi period. It flips from one side to the other. Because what happens here, it's y over x, y over x, y over x. If this is y over x, they're both positive. Here you're positive y over negative x. Here you're negative y over negative y, or negative x, excuse me. Here we are x over negative y. Aren't y over negative y over x, sorry. Aren't y over negative x the same thing as negative y over x? Those are the same. Same thing with here, negative y over negative x is the same as that. The sign, SIGN values, stay the same. So the reason that tangent is just replicated within its own period, the time it takes to repeat itself is 1 pi. Whereas the time it takes sine and cosine to repeat itself, you have to go completely around the circle to do it. So the period of a pi or period of cosine or sine is 2 pi before you get complete revolution.
Okay. Yeah, that makes sense.
Okay. That's why that occurs. So your tangent values wind up doing stuff like this. And we'll graph that and shift that and do all that stuff in a week or so. Okay. The regular algebra 2 class, the regular algebra 2 stuff is doing that right now. You guys are going into a lot more depth of all the trig stuff.
Just remembering there's a load.
It's all built off those triangles, guys. It's all built off those triangles. So let me show you. Where did I put my notes? Oh, there they are. That's not them.
Guess we picked yours.
Ah, that's funny.
It was worth the sound.
It was. Let me show you what happens. What we're going to do is this. What angle has a sine of 1/2? And it's a very,
69.
Sine
90 degrees.
hold on. The very easy thing to set up with these, first thing you do is try to identify which of the two triangles you're working with.
30, 60, 90.
Yes.
We're working with 30, 60, 90 because we have 1s and 2s. We okay on that? So what I want you to do is get in the habit of just drawing this out. We have 1, √3, 2, 30, and 60. Which of those two angles has the sine of 1/2? The 30 degree. So I know this has to be the 30 degree angle. Now, what I want to look at is, remember, sine values are between first and fourth quadrant. Am I looking for the angle that has a negative 1/2 or a positive 1/2?
Positive.
So my answer is going to be positive 30 and
Negative 60.
no,
Positive.
no,
Negative.
radians.
Pi over 6.
There you go. That's all it is. Because I'm looking for within this parameter between negative pi over 2 and pi over 2, what angle has a sine of 1/2? Pi over 6. That's what that is. That's all that means. Okay? Remember, this is asking you what angle has a cosine of negative √3 over 2. 30, 60, 90, very good. We know it's got to be a 30, 60, 90.
Wait, no.
Yes, it is.
30 degrees.
It's a 30 degree angle again.
30 is basically good.
It's your 30 degree angle. But now you have to think about, okay, I'm looking at a cosine value to be negative. Cosines range between first and second quadrant. Which one has the negative cosine? That one, the second. Now this one here gives me a 30 degree, which means it's the reference angle coming up, 30 degrees.
So it's 150.
150, or
Oh, I spelled
5 times 6?
5 pi over 6, very good. Because it came up pi over 6.
Why don't we say negative?
It's coming up first. Yep.
Why don't we say like negative 5 or 6 or something?
We don't say negative pi over 6 because negative pi over 6 would drop you fourth quadrant,
That's the same
and it's the same thing as a positive value. Remember, we're looking for the continuous to come through.
Yeah.
All right? Is it starting to open up a bit?
A little bit, slightly.
It takes a little while to get used to it.
Just sitting there like just talking.
All you have to know is pi over 6, pi over 4, pi over 3. Everything else just bounces off.
Cosine, that cosine negative 1 is 0.
Yep. Cosine inverse. What angle has a cosine of 0? One of the quadrantals. That narrows it down. So you have a 25% chance of getting this right.
That's about as close as I'll ever get. It's gonna be my grade on the test. 25%.
So remember, all you have to think about here is my cosine values go between first to second quadrant. Your ordered pairs are at 1, 0, 0, oops, and 1, negative 1, and 0. It's the top one. Why is it the top one?
Because the cosine is the y.
What?
What? No, it's
I don't know what that.
no, it's just
X divided by y.
no, cosine is the y.
It's the x. Guys, remember, cosine is x over r. On that vertical, it's 0 divided by 1. Therefore, it is pi over 2, or 90 degrees. It's here.
It's there. It's the y.
Okay.
It's the y.
Tangent. The inverse tangent of negative 1.
Is it like negative 1 over 1 or reverse?
We'll get there. First thing you gotta try to figure out is which triangle is gonna give you 1 or negative 1 for a tangent. It's gotta be the 45, because the 45s have the same sides, 1 and 1. Now think about tangent. Your tangent values starts at pi over 2, not including it, comes down to negative pi over 2, not including it. If I'm looking for a negative tangent value, which one am I going to drop into, first or fourth? I'm going to drop into fourth. You guys are telling me it's a 45-degree angle. If my parameters between negative pi over 2 and pi over 2, isn't this just then negative 45? Or negative pi over 4? The only one of these that you find inverses with, to use a reference angle to find an obtuse angle, is cosine. Everything else is just a negative value. Sines and tangents are negative angles. Cosine will be an obtuse angle. Okay? Sine and tangent will be, you can have negative acute. Cosine, you'll have obtuse. No negative angles. All right? All right. Inverse tangent of negative root 3.
So it's going to be negative 3 over 1.
Correct. What triangle
It's this 30, 60.
We know it's a 30, 60, 90. 'Cause it's got the root 3. Which of those angles will give you a tangent value of the root 3 over 1? 60. So I know that's got to be the 60-degree angle. Remembering that tangent goes between first and fourth. It's negative, so what does it have to be then? Negative 60, or very good. Negative 60 or negative 5 over 3. I think there's one more I wanted to do. Cosine 1. Inverse cosine of 1.
It's the first one. It's the first quadrant. It's the first quadrant. How is that right?
But here's the trick. A lot of times if it's a sine or a cosine, you've got a 0 or a 1. You have to be dealing with a quadrantal. If it's a tangent, you're dealing with 1. It's always going to be a 45-degree angle. Cosines go from here to here. 1, 0, 0, 1, negative 1, and 0. Which one of those is the cosine? Gives you cosine 1 is at that one. Which is it? What's the angle measure?
It's the pi. No, it go over 0. Yeah. Wait, cosine is y.
No.
If you went fully around, yes, 2 pi. But since, remember, I'm only looking at my parameters for cosine, it's going to be between 0 and pi. The cosine of negative, the inverse cosine of negative 1 is pi. Inverse cosine of 1 is 0.
Wait, 0 is a radian?
And 0 is a degree.
Zero's got 2 big eyes and a big nose.
What this is going to allow you to be able to do over the course of the next day or so is the following. We will. We'll do this tomorrow so you guys can get an idea of where it's going to happen.
Is this like, do we have to take like the cosine and figure out the angle is, and then take the sine and make the big 3 around the graph, and then figure out the location angle, and then make it equal like 1/2 sine of that is all 1/2?
We'll get there. Hey guys, ladies and gentlemen, we're still going here. Come on. What this is going to happen to do is it's going to allow us to build on this another step, which basically gives you order of operations. Here when you're dealing with order of operations, you're just looking at something with parentheses. When you're dealing with parentheses, you work to the innermost. This is asking you what angle has the cosine of root 3 over 2. So what angle has the cosine of root 3 over 2? Which angle is it?
30.
It's 30, okay? 30 is pi over 6, right? So first simplification is cosine inverse root 3 over 2 is pi over 6. So what's the sine of pi over 6?
Oh, do we have to draw like the big circle and draw that many degrees over and find the triangle?
What's the sine of 30? Done.
Wait,
So the sine of the inverse cosine of root 3 over 2 is 1/2. It's a composite problem.
So really, you should just like figure out what angle it is and then use the exact same
Yeah, that's it. All right. You're going to be able to do that if you were given.
oh, now we gotta reverse it.
That's the tangent of the cosine of 5.
See? Inverse of cosine.
You can go through, we're going to talk more about it. We can do it off sidelines too. It works the same way, all right? It's not a really complex thing. They do a lot of this in pre-calc. So we're just going to start doing it. It's fun.
Does that mean just secant or does that mean intersecant?
Yeah, we'll talk more about this stuff tomorrow. Let me give you the right page.
Just want to make sure I write my homework down. I forgot. You write it on the board all the time. I do. I just kind of forget. I get started wrote down. And then I forgot why I wrote it down.
Just one of those
Because I used to write my homework right there. It's all plastic.
You gotta spend on this one.